Graphing lines giving a point and a slope. You need a starting point, so apply at the point 1 in the x, 2 in the y. From that point, this tells me the rise over the run. So I'll rise 1, run 2. This is a graph of the first line. Again, you need a location of where to start. Negative 3 in the x, 1 in the y. Slope says to rise 3. So 1, 2, 3, and over negative 2. Negative 2 puts me in the side. So if you look at the slope, it's going downhill, so it is negative. The slope is going uphill, so it's positive. Starting position for the third one is over 4 and up 5. And now the slope of that is 0, meaning there's no slant. So it's going to be this horizontal line. Looking at the next graphs, this is a little bit different information. I'm given a starting point, but it looks a little bit different. It's not an ordered pair, but it's a value on the y. So a b is really 0, 3. So it's a y-intercept, so it's going to intersect the y-axis at 3. I will rise 1 and run 4. Notice the slope isn't very steep. 1/4 isn't very steep, and it's in a positive direction. Starting position on the y-axis, called the y-intercept, is negative 2. And I will rise 3 and run 4. Be careful, the 4 is in the negative direction, so again I'm going to rise 3 and run. I want the negative direction, which is this way, so my slope is in the negative or downward. Y-intercept is 1, positive. Now this negative here doesn't really belong with the 2 or the 5, it's kind of in the middle, so I've got two choices. I could apply it to the 2 and say rise negative 2, which would put me down 2 and over 1, 2, 3, 4, 5. Notice the slope is in the negative direction. Or I could have done it the other way. I could have rise 2 and run 1, 2, 3, 4, 5 in the negative way. As long as the slope is in the negative direction, it can be either applied to the 2, the rise, or applied to the 5, the run. The next three problems have to do with this form of a line. And if you look at the form of the line, m in this position is your slope. So this value right here is my slope. B, the y-intercept, is located at the end. It's not with the x-coordinate. It doesn't get to change. It doesn't get to move. So the y-intercept on this is 2. So I'm going to go up 2, make a dot. The slope is 2. Well, when I look at 2, I can see it as a fraction. Rise 2, run 1. Notice I have a positive slope. I'm going uphill. My slope was 2. In this scenario, if I want to transfer it, it's going to look like 0x minus 4. So I'm going to go to the y-intercept of negative 4. And the slope is 0, so there is no slant. So it is what we call a horizontal line. In the last scenario case here, we have negative 1 as my y-intercept. And negative 5, and if you recall, I could put it over 1. Negative 5 means you rise negative 5, which means you drop 5. 1, 2, 3, 4, 5, and over 1. Notice my slope is negative. Another way I could have done it was rise 5 and go over a negative 1. So actually my line should be a little bit steeper than applied there. In the last case, it again is trying now, I've given you a graph, can you find the slope? Let's just double check. The y-intercept should be 3. There it is. Now to get a slope, if you recall, we count rise over run. So I'm going to find another point, which I kind of like these x-intercepts. If I count 1, 2, 3 over 1, 2, it's in a positive direction. Rise 3, run 2. Notice in the next case I have this negative 2 as my y-intercept, which is down here, and this line is horizontal. 0 slope. In the last scenario, I have negative 4 as my y-intercept. That's this point here. And what is my slope? I'm going to take that point and count 1, 2, 3, 4 over 1. Rise 4, run 1. Now, I went 1 in this direction. If I look at my line, it's going downhill, so it better have a negative. And it doesn't really matter if the negative's on the 4 or the 1, as long as the slope is negative.